Okay, I do. So okay, so you can follow for the base station. For the base station, traditional base station is all in one. They put everything in the base station. In the now they have a new idea. They call it open grid. Red means radio. It says walk. Open grid want to disaggregate a base station into different parts. So you will have radio part. They call it RU, radio unit. They also have distributed unit, central unit, and the cloud. So the basic idea is you will have cloud. Cloud may run core network. Function. Then one cloud they can have multiple DU. Each DU can have multiple CU, central unit. Central unit, distributed unit. Each distributed unit can have multiple radio units. So this is a tree architecture. In the future, the DU, CU may run on top of a cloud, on a server or a server farm. This server farm is combined with CPU, GPU, memory, hard disks. You can share. It's just like the cloud service you are using today. So in the future, you can turn on a base station or turn off a base station, just like the way you use the cloud resource today. So the problem now actually is you need to allocate the resource. How many CPU core you need to allocate to this DU? When you allocate more DU, they can support service more user. If you allocate less no user, you can reduce the resource, DU, the CPU, the GPU. So I told you here from the radio side, you will do radio sharing. Many users or many different companies, they can share the resource from the base station. You can also, since we told you everything is run on top of cloud. So the CU, DU, they may share the compute resource. This is currently open grid they are talking about. When they are considering AI rate. When we consider AI rate, means that we will introduce AI computation power. So you can have AI computation power, you can also share. The AI computation power will be shared by the base station or by the AI application. So that's what SoftBank is trying to come up with United States government. They tell the government they want to invest lots of AI servers for their radio access network. Also, unused AI resource will be used to provide AI service, different kind of AI service. So in here, you will see that different kind of resource sharing. When you want to share a resource, you will have the problem for QoS. You need to guarantee the quality of service. So here is the idea. These are radio. These are radio with unit. So radio unit. So you can see that the bottom one is radio unit. So radio unit, you will have base station in business area, in residential area. During the working hours, everybody move to here. At midnight, they come back. So the resource will be changed. The number of users connected to a base station will be changed. So, but in the past, each base station have their own server. Okay, so you are not able to share your resource. Even nobody use, you still have the server here. But in the future, if they want to run all the BU application on top of cloud, when you are able to run on top of the cloud, you can control resource in a central manner. So so you can see that. So this is the traffic volume requirement.
The teams didn't share the script. May I help you with this one?
Okay, you can show. Okay, so it shows you different traffic hours in different time. The traffic requirement will be different. So in different case, you can see that within one day, different DU, they will have different traffic pattern. It depends on how many users are here. So in case this is one DU, this one DU they require, for example, peak traffic volume is 9,500. So in case if you want to support this one, you need to provide resource more than this peak. When you provide resource for this peak, they are unused during midnight. So that's why you can share the resource. But during the base station and the unused, you can use for AI. So here is an example. They show you the blue one and the yellow one. The yellow one or the orange one, during daytime, everybody move to here. So we allocate more resource. We can allocate more resource, more computation power to here, to the business district. In the midnight, in the nighttime, everybody come back to home. So we can adjust the value, allocate less resource to business area and move them to the residential area. So this is a kind of resource sharing. So here, I guess is okay. So for the future, you will have different kind. We just mentioned the radio resource sharing. Resource sharing. For this course, we focus more on the radio resource sharing. So, for example, you have a fixed bandwidth for each base station. They can provide different color. Different color means different kind of service. So you need to dynamically adjust the volume for this one. So here is the background part. I guess we can stop here. Any question until now? Yes.
I saw that they are able to take part of the low distance.
Yeah.
Maybe like fully transform.
Oh, wait.
Would you, for example, transfer part of those functions to the DU?
Wait for a moment. Since the slide. This one.
Yeah.
So what's your question?
The split functions.
Yeah.
Physical data between the DU and the RU.
Yeah.
Is it like standardized?
Yeah. It's already been standardized by Orient Alliance. They have Orient Alliance. Orient Alliance already have this kind of standard. So this part is lower. They split the physical layer into two parts. I is a radio tower. They also have some analog domain physical layer processing. They will live in the RU side. Here, they also have part of the digital domain for the signal processing. They will keep in the DU side. So DU will split. You can see that we have physical layer. I physical layer. This is for signal processing. Then we can have MAC, ILC, and DDCP. So for DU, it's up to ILC. So this here they have an interface. This interface they call it F1 interface. Then you have so-called DU. DU is one part. SDAP is for data transmission. RRC is for control. In last week we mentioned about the CU, CP control plane, and the CU, CP user plane. User plane is to transmit user data. Control plane is to transmit control signal of the base station. So they already have a clear separation for this part. Yes. Here they just show you a ring. You also will have centralized management. It's also on the regional cloud. Yeah. The old cloud is Orient Alliance cloud. So they define the cloud architecture for running the ring. Last week, in ORAN architecture, we will have a SMO. This is service management and orchestration. So SMO is basically for network management and the deployment. We just mentioned we need to deploy CU, DU to on top of cloud. So they need to have orchestration function to deploy to onboard this ODU, OCU on top of cloud based on the requirement. So they also have so-called RIC. RIC is RAN Intelligent Controller. It's for resource optimization, radio resource optimization. So this is for network management. This is for intelligent control. So with this one, they can use to control the CU, DU, and RU. So in the future, ideally, everything will run on top of cloud. So in ORAN line, they have an interface, standard interface defined for the SMO to build up the cloud, to manage the cloud, to deploy the CU, DU on top of the cloud. Also, they include how to deploy the RIC on top of the cloud. So this part, so SMO, they will actually the RIC. They have two kinds of RIC: non-real-time RIC and near real-time RIC. They are using for different purpose. Long control cycle, maybe you update, you make a decision, make a new update every hour, every day. The long-term adjustment is run on top of here. Now, real-time RIC do less than it's less than 100 milliseconds. Your control cycle less than 100 milliseconds will be handled here. So the non-real-time RIC and the near real-time RIC, they will use A1 interface. ORAN lines define A1 interface for this part. SMO also need to control the RIC, so they define O1 interface. SMO also need to control CU, DU, is also O1 interface. Then CU and the DU, this interface is standard by 3GPP, they call it F1 interface. DU and the RU, they define ORAN alliance. Okay. So let's use different color. All the yellow one are defined by ORAN lines. Here, they have front hole interface. The front hole interface is also defined by ORAN lines. F1 is defined by 3GPP. So ORAN lines, the purpose of ORAN lines is they define the open architecture, define clear interface, such that manufacturer now you can purchase CU, DU from different vendors. So CU, DU can run still, even until today, you can run on top of server. So you can use dedicated server for running a CU, for running a DU. But the problem is you are not able to share the compute resource. So if you are using on campus, for example, in our campus, for a private network, maybe you will buy dedicated hardware for that. But if you are an operator like AT&T, they have thousands or tens of thousands base stations in the future. Because as we mentioned, in the future, you need to have higher data rate. So you need more base station. Each base station, if each base station you want to install one server, so the investment will be huge. So the idea is similar to cloud. For cloud, they can have common resource. You can have a cloud of servers, CPU servers, GPU servers. Then you can distribute the compute resource to different CU and the DU. So everything in a large scale deployment, everything can run on top of cloud. When you run on top of cloud, you need to have entities to deploy this kind of service. So in addition to manage each base station, each module, you also need to use orchestration to create the container, for example, for the CU, for running a CU. You also need to do the life cycle management for the CU or DU. For example, we just mentioned during the midnight, maybe nobody is using the base station. You can turn off some of the base station to reduce the power consumption. The power consumption for 5G, 6G will be significantly increased because you want to have higher data rate, you want to have more base station to cover everywhere. So that's the issue, that's the problem. Any question? Yes. Next page. Okay, the idea is that during the daytime, if we have this is you can consider that we can have 1, 2, 3, 4, 5, 6, 7, 8 in total 8 resource unit, 8 compute resource. Okay, computation resource. This is a cloud resource. You can count as number of CPU, GPU in total. So they will allocate 6 units for business area for running the DU in the business area, and for 2 DU to serve the residential area during daytime. But after in the nighttime, the only reserve 2 resource units to business area. The remaining resource unit will be used to serve the residential area. So how do they do it? Because everything on top of cloud. You can allocate more CPU, GPU to residential area and business area. You can adjust it dynamically. So if you want to do the adjustment, you can just use this one. Orchestration, you can allocate more computation resource to the CU, to the DU, that you are able to serve more users. So this is the idea. You run everything to the cloud. When you move everything to the cloud, you can dynamically adjust the resource. So actually, this is similar to the way we just mentioned. If you want to consider AI rate, you can consider this is the total cloud resource. the total cloud resource. In midnight, you reserve less for radio access than you can have spare resource. They can be used to provide AI service. But during the daytime, you need to allocate, reserve more resource to support the radio access service. Then you only have fewer resource. The fewer resource can be used for AI. So you dynamic measure, your major service is a rate. You want to guarantee everybody can use the network service. So you need to provide more than required. But since you provide more than required, so you will have unused resource. Unused resource, they will be shared by the AI application. So that's the basic idea. Yeah.
So you need that EU cluster to be closer to the
Yeah.
user. So,
Yeah.
for instance, in the example you were showing, where you have the business district and the residential district, imagine that maybe the cloud cluster is in the residential part. So if you need low latency service in the business district, how?
Okay, for low latency, the major problem for latency is that you have user connect to the RAN. The RAN actually you can have CU close to the user. So, but everything you need to go to the core network. Core network, actually, what you are doing is you want to use your handset to go through the internet. Okay, so the latency comes from here to here. So latency is quite high. The idea for to support low latency. First of all, you can increase the speed for the UE. Okay, from 1 mega to 100 mega to 1 gigabit per second. Yeah. If we need higher speed, this is one possibility. But another limitation comes from the round trip delay, right? So the idea is that you will have a server, application server in internet. Originally, for example, Google. If you want to use Google, traditionally you need to connect to United States server. So it takes a long time. But how can they reduce the transmission delay? They can have a copy of application server in Taiwan. Then you don't need to go to United States. So they use cache to put many people, you want to use something, I have a cache server here. But in case you are considering a driving car, a safe driving car, you cannot go to the central cloud server. So they can consider as your application server here, more directly in the base station. Okay, they call it mobile edge computing. The concept is move something unique close to the user, then you can reduce the propagation delay. So this is one of the solutions they use. So So to remember, the resource sharing can be done at a different level. We can share the AI resource. We can share the compute resource. We can share the radio resource. In this course, we will focus on the sharing of the radio resource. And this is the fundamental concept. Why we need to, since we want to do sharing, resource sharing. So when we do the resource sharing, some will get better service, some will get worse, less service. So they will have different quality of service based on your application. For example, self-driving car, you need to have a short delay. For multimedia service, maybe you need to have high bandwidth. So let's stop here. Any question until now? We show you basic concept for Open RAN. We show you the trend in Open RAN. We try to separate control and the user data. We separate the hardware and the software. Then after separate the hardware and software, we are able to run everything on top of the cloud. Then we can share the resource. We can dynamically adjust the resource. So let's start on our course. We mentioned the first part. In this semester, I will introduce. First one is application. From application, we can know what user need. Then we will tell you different application have their QoS requirement. Then we will show you how to the network, how can we allocate resource in the network to support the QoS. So in this semester, first of all, we will quickly go through multimedia application. Most of them are well known for you, so we will quickly skip this part. Second one, we will show you fundamental knowledge concept for QoS. Then we will show you QoS mechanism. QoS mechanism are mechanisms provide to the network to support QoS. So multimedia application, in general, most of them are still using today. Streaming video, streaming audio, collaboration, one-way interactive multimedia message, gaming, digital money transaction, MP3, video, and the video support shopping. Even now, you can also know, we can also have AR, VR service. Long-term distance education, video, audio, conferencing, file sharing, geolocation service, safety, gambling, entertainment. So with QoS, application can improve interactivity, reduce jitter, provide continuous video and voice experience. Without QoS, the quality of the service may not be good, latency may be high, your experience may be worse. So here are a list of streaming service. I guess we can just quickly go through it. The basic requirement for video is low latency, low jitter. P2P, we want to have low loss, okay? So the first one, so we can see that when you are using video streaming service, you are watching the TV. So what do you care about? Latency, okay. Latency or delay. Anything else? Quality. Quality. Video quality. So how can we characterize the video quality? Resolution, okay. Resolution depend on your depend on what? Resolution, yes, is one of the, yeah, but when you use higher resolution and the lower resolution, how does it affect the network? From network, bandwidth, okay, bandwidth, the data rate. Right? You want a higher resolution, you need to have higher data rate, higher bandwidth. So latency is what? Bandwidth. Any other for video? Audio, video? Do you use Skype? How do you think about the quality compared to when you are using telephone? Another one actually is jitter. Delay jitter. Delay jitter means that if you have a packet comes very quickly, then something you will delay, or even you are watching a TV, you want the TV will show very smoothly, right? You don't want to have one very smooth, then they stop, then they smooth, they start to play again. So if your delay is constant, your frame will, your movie will be very smooth. If the packet you transmit at different variation, high variation, they will introduce delay jitter. Jitter actually is the second. You can treat it as a variance of the delay. Variance of the delay because delay jitter. So when you have high jitter, means your packet transmission sometimes very quick, sometimes very slow. They have big difference. So you will see the lag on your screen, or you will find out your voice will not be clear. So here are some important ones. So you can find out steady data rate is better. If you don't have steady data rate, your delay will be, your delay jitter will be increased. Next one, P2P. P2P, you are doing file sharing. So what is the major concern for file sharing from network point of view? What do you care? What? On the file, okay. So it's still the data rate, right? You want to have quick transmission. How about the others? You want to have low latency, you have higher data rate, you can have lower latency. Any other? The burial rate here. The burial rate or packet error rate are important. Because when you share a file, your file should be able to read. Right? If there's any big error, you are not able to read. But for voice and the video, when you watch a TV, even you found they have some peggy error, you can still tolerate. Okay, so clear rate, peggy error rate is one important for this kind of service. Okay, let's take a 10 minutes break. You can quick. Young, do we upload the slide to the, please check. Okay, so if we have a line group, so if you want, we have line group, we have a HackMD showing everything, showing our slide. So if you don't know how to do it, try to check with our TA Young. Okay, let's take a 10-minute break. Thank you.
For Professor of this one. I think it's different.
This one?
Yeah, for this one, you should the cloud or this one or Google. Or the slash or you.
You can check.
And for this review, I will review it.
Okay, yeah, thank you. Yeah.
Professor, the hyperlink on Hackam before this slide is empty. So I think you need to share the folder.
The flyer to you.
Yeah, the folder directly. So whenever you have update, I can update it directly. Do you use Cloud for this one?
那也嘞,
Okay.
I guess I should have one from.
I have last year's.
Yeah.
But
then
I'm afraid it's the old version. You have some update.
for this one, I don't have update for session one. Let me.
Okay, thank you.
Okay. Stem opening, I guess I already put it on the. Here, this is opening.
Opening.
Yeah, this
Okay.
is opening.
Okay.
Okay, thank you.
Thank you.
Okay, let's come back. Next one is digital money transaction. A digital money transaction, you know, the important part is fail rate. You don't want to lose 1-0 when you get the money, right? So entertainment is also like video, audio, file sharing. This is data transmission. Email, the correctness of email is quite important. So it's fail rate. Gaming. What's important for gaming? Latency. Yeah. If your network have high latency, 10 years, 20 years ago, I saw an email. They said that they use 2 people start to cut the others, but one of them delay is very low. So after even he start to kill his enemy, but his knife is still on hold. So to the end, he was killed. Then he found that the gaming, they need high speed. So I guess you have a good experience for that. So telemedicine, you need to have a very clear screen, low latency. Otherwise, something may happen. So different applications have their different service. I think we can quickly skip this part. So there are some protocol. So I think the most important part for the chapter 1 is tell you different kind of service will need different kind of you will have different experience. So different experience you rely on different network service to ensure your core QoS. So we will show you what is QoS. So in this chapter, the most important part, we will have 4 parts. The first one, we will define what is QoS parameter. Then we will show you in the previous one, we show you multimedia application, but we just show you in a qualitative manner. We don't show you exact what is the requirement from the multimedia service. So we will show you the requirement. Then we will show you QoS service. Then we will show you how to realize the QoS service. So the factor or the component that affect the performance, we have basically we have user, we have host machine, we have application, we have network. It looks like this. We have host, we have user, we have application, we have network. Okay, we have network. Network are interconnect. Network are interconnect by different wire or wireless network. So you can see that from this video, you can see that for the network, we have router, we have cellular network. Basically, they have lots of hardware and software. In your machine, you will have application. You also have hardware. You have hardware, network interface card. You will also have network driver and the protocol. So the user, what's the user? User are human. or non-human, they utilize the multimedia application. User perspective, they will influence the evaluation of the multimedia application. Then we also have host machine. We also have a machine, user machine. Machine is a device. They operate the multimedia application. Normally, we can simply classify the machine as source and the destination host. Your machine consists of processor, CPU, GPU, storage, your hard disk, your RAM. You also have display, operation system. Application is the one that provide you the service. For example, you want to watch YouTube, you will have YouTube application. YouTube application, one of them is a video decoder. Network is the network component that transmits the multimedia content. For the network, they also have hardware and the software. Hardware, the switch, router, the network interface card, the NIC card, gateway, firewall, they are hardware. But you know, this hardware component, they also run some software on top of it. So the software are running the network protocol. For firewall, they may also have some virus detection algorithm. So upper part is a user application. The lower part is network. In last hour, we show you the concept for application. In this course, actually, we focus on network. We want to tell you how network provide the service to the application or users. So, multimedia, suppose we can use the QoS, quality of service. We can use the term of QoS service to describe the multimedia supported. So we have two perspectives. One is from network perspective. One is from application or user perspective. Next hour, we show you from user perspective what we do. From user perspective, normally we will not use QoS. Maybe we use QoE, quality of experience. Okay. The quality of experience, normally we consider presentation quality of the video, such like the resolution we just mentioned, responsiveness of interactive video or interactive voice. This is depend on the delay, depend on the delay jitter, the sound quality, hi-fi or high fidelity or not. For network will provide service to application. So from network point of view, we need to define so-called network QoS parameter. One is the latency. The first one is latency. Latency is the delay of packet transmit across the network from the source to the destination. This is the latency. Reliability of the packet transmission measured in terms of packet rate or data rate. Throughput is the bandwidth, is the data rate we mentioned. In this course, we normally use throughput. We don't use the bandwidth or data rate. User do not concern. User, for you, you don't care whether you use Wi-Fi, you use cellular, or use wireline network. You just want to ensure your quality of service is good. For example, you want to watch a YouTube. You don't care whether you just need to, for example, want to have 10 megabit per second. You don't care whether it's come from Wi-Fi, come from cellular, or come from your laptop. Yes. Okay. QoE is from user's perspective. QoE, sometimes different users have different experience. It's more, everybody will have different experience. But in order to have a good QoE, network should guarantee the QoS. Okay, so you can say that QoE is more string requirement than QoS. QoS is from network perspective. Network can tell you, I can support you 10 megabit per second. Okay, this is the QoS they can support. I can guarantee 10 megabit per second. But for users' experience, it could be good, very good, or it's still okay. Okay, different people, for example, different people, they may, for the same transmission data rate, but for the voice, different people may have a slightly different experience. So QoE is more subjective. The QoS is network. We can measure it. Everybody can measure it. It's more objective. Okay. Any other question for QoS, QoE? QoE is from user's experience. QoS is from network's perspective. So user, they do not concern how the network manages resource, but user concern the service provided will impact the perceived quality of application. Yes, user care about the QoE. The network need to provide the QoS. So we use this video to show you. We have application, we have network. Network need to provide QoS service to the application. Now the problem is, we just mentioned we can provide QoS service to the user, but how user need to have a mapping from its QoE to application requirement. Okay, user need to tell the network its application requirement. This requirement normally we call it QoS requirement. User give QoS requirement to the network. Network provide QoS to the application through QoS mechanism. Okay. User specify the requirement. Network use some mechanism to provide QoS service. Any question here? This is the QoS model we just mentioned. So in order to define the QoS model, the most important, the first question is, we just mentioned, user need to specify the QoS requirement, application requirement to network. So the question is, what are the important information need to be considered for the QoS application requirement? So the desired quality, we just mentioned QoE, desired quality of application related to users' certification, which is subjective. Different user for the same network service may have different experience. So the problem is how to map the desired quality to QoS parameter. To a certain parameter that the network can use it to guarantee the service. And what are the criteria required to be considered in the mapping? So we have QoE. QoE need to map to QoS, to map to the QoS parameter. So I want to watch your video. So you need to tell me how many bit per second. What's the throughput you require? What's the latency you require? So finally, the key issue is what are the QoS parameters? The QoS parameters are used to specify the application requirement. So the key is the first thing we need to do if we want to support QoS. The first thing we need to do is we need to define QoS parameters. Then the second issue is what are the QoS mechanisms the network need to be used to support the QoS. And what kind of QoS service level can network offer? Okay. So the first question is we need to define some QoS parameters such that the network knows the requirement from the user, from the application. The second one is network need to manage its resource using the QoS mechanism to provide QoS to users. So in order to provide QoS to user, we also need to define how many QoS, different level of QoS we need to guarantee. So here are some questions. So finally is how to define the relationship between the QoS service and the application requirement. So from the figure here, if you remember here in this section, the outline, first of all, we need to define QoS parameter. Then we will show you multimedia application requirement. So requirement will be specified in terms of QoS parameter. Then the network will provide QoS service to the application. So application requirement will be determined in terms of what? Application requirement will be determined in terms of what? QoS parameter. Okay, because your requirement, how many of you need to get some funding from your parent? Please raise your hand. No? Okay. You are self-funded. Great. So when you are a kid, you want to get some money from your father or mother. How do you? It's your application requirement, right? You need to tell your parent how much money, or you need to tell them something fulfill your requirement, you need to tell them, I need transportation, I need food, I need something for my pet, for example. So each one of them is your application. Okay, your food is your application. How do you convert your application? You can say that I want to eat a lunch. But finally, how does your parent knows what your lunch means? You need to tell them the lunch. He can tell you lunch, $1, $1 for your lunch. Is it good or not? Maybe good, maybe not, but it depends on your requirement. You have an expectation, but if you just tell them, I want to eat a lunch, they don't know how to quantify the lunch. So you need to tell them, I need to have $10 for my lunch or $20 for my lunch. This is the QoS parameter. The money, the value, the money is QoS parameter. You need to specify your QoS parameter, then your parent need to see what kind of QoS level can be provided to you. For example, in total, they tell you in total, you can only have $1,000 $100 per week. Then they need to tell you how much of that the first priority for the money should be used for your food, for your transportation. Entertainment should be kept in the lowest level. So you need to define different priority level. How many QoS level, different QoS level will be all your applications. You will have different applications. User will have different kind of applications. Your application should not be treated equally. They can be treated equally, or they cannot be treated equally, depending on different kind of QoS service you need. So back to here, QoS parameter, you need to map your application requirement in terms of QoS parameter. Then the network knows your requirement. You can just tell them, I want a lunch. You need to tell them, I want $10 for my lunch. So QoS parameter, the first thing, most important part is QoS parameter. According to some service we just mentioned, throughput or bandwidth is most important. You want to know how many data rate you need for your application. Second one is delay, or we call it latency. Both of them are the same. Third one is variance of the delay variation. Normally we call it delay jitter. Quickest and the lowest one, you will have average, but average value you will have upper bound and lower bound. The difference between upper bound and lower bound is your delay jitter. For example, your latency on average is 10 milliseconds, but sometimes it will go to 12. Sometimes you can slower than 8. So your latency is 12 minus 8, 4 milliseconds. Higher valence is not good for your interactive video or voice. Okay, you will feel not comfortable. So delay variation is also important. Next one is loss or error rate. Packet loss or packet error rate. It depends. It is quite important for money transaction, for file sharing, for email. The last one we do not mention is fairness. Why we mention here? Because for wide network, in general, we have many users share a common resource. So we still need to consider the fairness among users. And each user, you may have different time. Now, everybody know that you can run many applications in parallel even on your headset. Okay, so you need to give them some different priority. Like you need to consider the fairness among different applications on your headset. So fairness is also one of the QoS parameters. Here, I should say the QoS parameter we mentioned here is the common one. They are common one we use for the network. But in addition to that, you can also define the QoS for yourself. For example, security. You can also treat security as a service level. The QoS, you can have high security or low security. If you want to have high security, you need to enable some security mechanism. Then you will affect the rest of them. You need to have higher resource to execute that. Any question here? Here, this one is important. You can use, if you understand the QoS, you can apply it to your daily life. For example, how to allocate your money, how to allocate your time. Somebody, I saw that somebody also in IC design, you can also consider the QoS. For example, IC design, if you want to design SSD, you want to have multiple rewrite. So rewrite your speed, the rewrite speed is some kind of QoS for the IC. So same concept you can apply to different fields. But now first thing to be known is you want to use the minimal resource to guarantee the QoS. Okay, we mentioned last week we have over provisioning. You provide much more than required. Another one is you need to use QoS mechanism. Given fixed resource, then you need to allocate your resource. This is the QoS mechanism. So the QoS mechanism you can consider for different use case, you can consider different QoS mechanism. So here we quickly define the parameter. First one, throughput. Throughput is an application perspective. Throughput refers to the data rate. Important, we define the QoS parameter. Important of the QoS parameter, you need to know the unit. You need to know the unit. Throughput is measured in terms of bps, bit per second. Sometimes we call it bit rate or bandwidth. So bandwidth is a network resource to be properly managed and allocated to application. So required throughput depend on application characteristics. Stream video properties will different resolution. For example, they will affect the throughput. So for example, here they take video as an example. If we just mentioned, your throughput are network resource. If your throughput is given, how do you ensure the quality of the video? This is what we are doing now today. If everybody, you use YouTube, right? When you use YouTube, when you have very high data rate, your network can have high data rate and a low data rate. What's the difference? You can still see the YouTube, right? So what is the difference? Resolution, right? You can have different resolution. lower data rate, you can reduce the resolution. Then you still can see the movie. Okay, so this is what they are doing. You can reduce resolution. Resolution is measured in terms of number of pixels per line, per column, and you also can reduce the color length. Okay, how many bits you use to encode a pixel is the color length. You can also reduce the frame rate. Now, for example, you can have 20 frames per second, or 25 frames per second, or 10 frames per second, 1 frame per second. For surveillance video, actually you don't need to have 25 frames per second. Maybe 1 frame per second is good enough. So reduce the frame rate, you will reduce the smoothness of the video. You can also reduce the color depth. You can use true color, or you can use 8 bit per pixel. So 8 bit per pixel, you can have 256 color. True color, you need to have 24 bit per pixel. Another way is whether you enable compression or not. So reduce the bandwidth consumption at the expense of the image quality. So example, you have different encoding mechanism. So when we are talking about bitrate, in general, we have two kinds of. We simply classify the application into two types. One is CPR. CPR means your data rate is a constant. Another one is VBR. VBR means your data rate requirement is available. But how do we determine the QoS requirement for CPR and VBR? For CPR, very simple. This is S is your allocated bandwidth. Y is user specification. So for CPR, you only need to have a constant bit rate. This bit rate, for example, 100 kilobits per second. So when you are able to provide the service 100 kilo, service specification is what? You provide 1 megabit per second, the certification will not be increased. So this is CPR. For VPR, very simple. You will have minimum bandwidth and the maximum bandwidth. Higher than maximum bandwidth, your certification will not be increased. Lower than minimum bandwidth is not acceptable. Okay, you can do. So on this video, we know that if you want to characterize the VBR service, you only need to have one parameter, the data rate. If you want to characterize VBR, you need to have two, minimum and the maximum. In general, VBR is a special case. CPR is a special case for VBR, where maximum equal to minimum is CPR. With VBR, we need to define so-called burstings. Burstings is your peak error rate divided by your mean error rate divided by peak error rate. So what is the peak error rate? Peak error rate is the maximum error rate for your service. Mean error rate is average error rate. Average data rate, average bit rate. So burstings, higher burstings is. So now we are network. We want to allocate bandwidth to a VBR service. which one will be easy? First is, so what's the base? First is, what's the unit for business? First question. What's the unit for business? It's units, right? Because PR rate divided by PR rate. So what's the range for business? 0 to 1, okay? Your data rate will not be greater than 10. So it's 0 to 1. So first is is 0 to 1. So it's easy to allocate bandwidth for the VBR service. Which one? Higher value or lower value is more easy for you to allocate. Here can be 1. So which one is more easy for you to allocate bandwidth to the user? Lower, for example, 0.1. Those who think that lower value of business is easier for you to allocate. We are talking about VBR service. The business is a characteristic of the VBR service. Okay, so we can have low value, low business, and high business. This factor, because this factor, they have different definition. Somebody use mean divided by p. Somebody use p divided by mean. But in this course, this textbook, they use definition like this. So the question is, if you are a network, it's more easy for you to allocate resource with a low value of business or a high value of business. Okay, any question for do you understand? So everyone need to make a decision, need to vote for that. If you are a network, you need to allocate bandwidth for VBR service. For those who think low value of business is easy for you to allocate a resource, please raise your hand. Hello? For those who think high value will be easy for you, please raise your hand. If you don't raise your hand, you can stand up to answer the question. Okay, again, I need your hand should be higher than your head. Okay, my QS requirement I do not specify my requirement, so I apologize for that. Again, you are now the network operator. You need to allocate bandwidth to VBR service. The VBR service, one of the way to characterize, because VBR service are characterized by minima and the maxima. Okay? Your service data rate would be like this. So this is your data rate. This is the maxima. So this is the minimum. You also have mean. Okay. You will have mean value, you have maxima, peak, and the average, and the minima. Okay, we have maxima and the minima. We also have a mean value. So the question, everyone need to make a decision. Question is, higher value of business is easy for you to allocate bandwidth, or lower value is easy for you to allocate bandwidth? High, please raise your hand. Higher than your head, okay? Okay? Okay, thank you. Low. Okay, so why is low? Anyone want to clarify?
There is less variability, so it's difficult to predict the traffic.
Okay, we just mentioned. So let's back to fundamental. If you want to allocate resource to two kinds of service, it's easy for you to allocate CPR or easy to allocate for VPR. This one or this one? You don't know. You don't know. If from your parent point of view, which one is more simple for him? For VPR service, you tell your parent, minimum, I need 100 US dollars. Maximum, I need 1,000 US dollars. For CPR, you tell them 200 US dollars per week. So from your parents, their money are fixed. They have many children. So if everybody tell them minimum is 100, maximum is 1,000, is it easy for him or her to allocate budget to you? Maybe difficult. But this one is a constant value. So constant value is equal to what? Equal to 1. This is the constant value. It's a CPR. CPR is very simple for a network to allocate resource. For VPR, it's difficult. It's more difficult. For the lower value for business, lower value means year. Higher value means year. So higher value means that the business, higher value of business, higher value business definition is like this. Peak to me. Higher value means that your peak is close to your mean value. Means that your deviation, the variation of your data rate is smaller. Okay, so when you try to allocate resource, it's much more simple. If you don't understand it, let's just back to here. Very simple for you to allocate resource here. But if this is very, very small, this is very high. The mean value, okay? The mean value, for example, the mean value is here. We don't know. But we still need to provide you with high bandwidth. So the variation is high. It's hard for resource allocation. Any question here? VPR and CPR, they are two types. In the resource allocation, you always need to care about that. Another definition of business is inverse, but we we'll keep the definition for the hub. Delay is important parameter, real time. So normally later on we will classify the service. So from the perspective of data rate, we have CPR and VPR. From the perspective of delay, we will have real time and non-real time. If you remember, we just mentioned real time, read, and non-real time. In that out, non-real time, we just said that the tolerance, delay tolerance is higher. Real time is shorter. So here, the idea is the same. From delay perspective, if you care about the time, the delay, you are delay sensitive, we call it real time. Real time, or we call it delay sensitive. Now real time, we call it delay tolerant. Something like that. Okay, but in here, we told you real-time application, they require to deliver information in a certain period of time. Long delay will introduce data missing. For example, when you are transmitting a video, your video is 25 frames per second. Okay, 1 second you transmit 25 frames. But in case of a delay, so every frame should be received in 1/25 seconds. So if your delay is 2 divided by 25 seconds, okay, your delay is more than 1 frame, then the previous one of the frames will be discarded. They will not change, they will not display 2 frames at the same time. So some of them, for video, for voice, when you have one of the package delay for longer time, we just discard it. Because you cannot replay the 1 frame transmit. For example, in the worst case, the delay of a certain frame is 1 second. You will not display a delay frame later on. So you will introduce data missing. User will, the interactivity between the user will not be happy. So when we are talking about delay, so from now we have 2 types of classification: CPR, VPR, real time, and real time. When we are talking about delay, we need to know what are the source for the delay. Let's use this one to explain. So this is the time, starting time, end time, smaller one, higher one. So here is transmitter, is a source. Here is destination. So we can use this figure simply characterize the delay. First one is processing delay. Processing delay means that when you want to have your video conference, for example, your video conference, your camera need to encode your face. So they will capture your face, start to do encoding. So do the encoding is processing. Then you start to transmit your video. So your packet, your frame, your image will transmit to your NIC card. your NIC card spend some time to transmit the packet. So this is the transmission delay. Then they will also have network transit delay. This is the propagation delay. Everything, it include the propagation delay, include the processing delay for all the components from the source to the destination. Then at the receiver, oh, sorry. The first one is transmission delay. Second one is, processing delay. Transmission delay is start from the first bit you want to transmit to the next bit. So the transmission delay depends on your data rate for the source. Then network transit delay is majorly depend on your propagation, your distance between the source and the destination. And for the receiver data, they still need to time to decode the packet. So they have processing delay from the transmitter. They also have processing delay at the receiver. They also have transmission delay at the transmitter. So it depends on the network speed. The last one is the network transit delay. So sorry, I know. Let's finish this part. So source processing delay. Source processing delay consider digitization. We just mentioned when you want to have a camera to transmit your video for video conference. So first of all, you need to encode. So this is the digitization. Then they also encode into multiple video packets. So this is the source processing delay. Source processing delay depends on the hardware of your encoder for the source, CPU, RAM, and the loading. So how many, if your computer are running multiple programs, so your loading also affect. Transmission delay depends on packet size. Longer packet size, you take longer time. It also depends on your throughput for your network. Third one is network delay. Network delay consider, for example, we just mentioned propagation delay from the source to the destination. They also have software processing delay for the protocol. They have extra one we call output queue delay, because in your packet will go to a switch. The switch will have multiple. Your switch will look like this. Your router will look like this. So they may have two packets come from different ports, but they want to go to the same direction. So here they will have queue, they will have buffer. So in each intermediate device, they will have output queue delay. So output queue delay depends on whether network is congestion or not, depends on your hardware. It also depends on your link speed. Finally, you also have the destination processing delay. So since the delay are different, so they will introduce delay variation. So each packet, even you go through the same path, the network congestion, the network situation will be different. So they will introduce delay variation. The delay variation is defined in terms of jitter. Okay, any question until now? If no, we can take a 10 minutes break, then we can come back. Okay, thank you.
She wants to apply for another government. Last year she failed.
Oh,
So this year she wants to try.
okay. Okay, sure.
I will be back.
Yeah, thank you.
Okay, we can start earlier than we can end earlier. So that's all we talk about delay. So delay, since the network will introduce delay. So they are some, normally we will consider it, no matter voice or video, they are transmit their packet regularly. So in a fixed interval. For example, you want to have a YouTube video, it will generate packet constantly. But go through the network, they will introduce some packet comes earlier, some packet comes later, some of them are on time. Okay, so this is the final result. This is the transmission, this is receiver. But when you encode the packet, you, for example, 25 frames per second. So your encoder will generate one every frame, one frame every 1 divided by 25 seconds. So at the receiver, in general, you will replay the frame constantly. But here, you will find out some of the packet comes earlier, some of the packet comes later. Then we have 3 methods to deal with the delay. First one is we can adjust the packet playback time. When we receive a packet, we just display it. In this case, in the first case, the user experience may not be good because some frame comes earlier, but the next frame, the distance, the latency between the next one will be longer. So you will find that since that your screen hold for a certain period of time. So this one is adjust. The first way to deal with the delay. First one is adjust playback point. Second one is when one packet comes earlier, you can still play back at this point. But for this one, I will play back the packet here, but I did not get any packet. So this packet will be discarded directly. So they will have a missing packet here. Third one is we add a so-called digital buffer. Okay, this effect comes from the jitter. So one thing we can use digital buffer when we receive a packet, put into the buffer, then I can play it back. Okay, so we have 3 methods to deal with that. Any question for this part? Everybody understand? It's quite easy, right? So can anyone answer my question? Why this packet comes early? How can a packet come faster than expected? I transmit in a transmitter. For example, this is 1 second. In a transmitter, I transmit a packet every 1 second. Why? This packet will come faster. The question actually is why we will have delay jitter. Everybody think this is quite simple.
I think like maybe packet 1, let's say 1 millisecond to get to the receiver.
Yeah.
Then when the sender sends packet 2, maybe 0.5 milliseconds.
Yeah.
So it comes later.
Well, comes later. Yeah. Okay. Because this is one. Actually, it could be this one. Okay. Actually, we are talking about the transmission time. So the latency actually depends on transmission time. So first one is take 1 millisecond, but second one just take 0.8 seconds, so it's me remind everybody, if you don't join us in this semester, we encourage everybody to raise questions. So when you are able to raise questions, in every week, you can get 1 point for the final score. Final. In this semester, the overall is 100. You can get 1 point per question per week. Means that you raise 2 questions today, you can get 1. If you raise 10 questions, it's still 1. But if you raise 0 questions, you get none. Okay. So this is the first rule. Second rule, we have 16 weeks in this semester. In total, we reserve 10 points. So means that you just raise questions, you can get 10 already. So to remember, when time goes away, you don't have time to check it, to get it back. So we have 3 different techniques. First one, adjust playback point. Second one, they don't adjust playback point, just discard. Third one, add digital buffer. So which one is better? Both of A and B, they will affect the user's experience. C is better, but we need to pay. Everything you need to pay. You need to pay for digital buffer. In the implementation, actually, what you need to know is how to design the size of digital buffer. Okay, digital buffer, the size of the digital buffer depends on what. If you want to, somebody asks you, tell you already take this course. We want to use digital buffer to smooth out the jitter. So how do you design it? What are the information you need to design your digital buffer? Bandwidth, okay? Any other? The jitter, okay? Digital buffer, okay, good. Jitter, digital buffer is to deal with jitter. So it depends on just how many packets you can complete. So it depends on the bandwidth. It also depends on your jitter. Higher jitter, you need to provide bigger digital buffer. So actually, I think when you are watching YouTube, sometimes when your network condition become very bad, you will find that it's queuing. Everything start there, then they start to queue the buffer. They do not discard the package, they did not break it up. They just use digital buffer to queue the buffer for a certain period of time, and they will break. Then you can still have smooth image. That's the technique we are using today, widely used today. Any question? Here we have several QoS parameters. First one related to bandwidth, second one related to delay, third one related to packet loss. So we already mentioned data rate, already mentioned delay, and the delay jitter. The next one is packet loss. Packet loss can be caused by network congestion. If you remember, we consider the output queuing delay. When we consider a switch, they have output queuing delay. The step you need to decide the buffer size here. So if the data rate is very fast and everybody go to the same output port, it will also introduce packet loss. So the facility, then one is due to this one, and another one is maybe due to timeout. Some packet is time sensitive, so you will have some problem. So due to congestion, it's also due to the transmission. When you transmit the packet, you will have error, you will maybe it's not recoverable, you will start it. But there are some techniques from the network to recover packet loss. Why do we need to have this one? Why do we need to have technique to recover packet loss? If you remember, if you want to make money transaction, you should keep 0 packet loss, right? You don't want to reserve when you send money 1,000 to somebody, you don't want to lose any 0. So it should ensure 0 packet loss rate. So in order to ensure that, because packet loss is not preempt, you cannot prevent packet loss. So you need to have technique to recover from error. So they have 3 different ways. First one is error correction. You add redundant bit. For example, you want to transmit 1 bit, but the bit transmit could be error. So you transmit identical 3 bits, 111. So when you receive 2 bit 1, you can use majority vote. Okay, this is error correction. Simple idea is you add some redundant bit in the transmitter, such that at the receiver you found the error, you can correct the error. This is error correction code. Second one is whenever you receive a packet, you find it's wrong, you request transmitter to retransmit the packet. Okay, so we call it packet retransmission. The packet retransmission is if you took the course for data network, this is we call it ARQ, automatic retransmission request. The third one is you can use codec at the application layer. For example, in your video codec, you can also use some method to recover some error. For example, in MPEG encoder, they will try to make differentiate your packet importance. Then they add important, they can correct some error based on, for example, you can use the previous frame, part of the information from previous frame to recover the lost packet. So there are three kinds. The third one is from the application. These two are from the network. So what's the trade-off in real situation in order to ensure 0 transmission? Both of them will be a problem. So simply we say that we have source and the destination. So we can use error correction code. Okay, you add error correction code at the source. We call it, normally we call it forward. Forward error correction. What does it mean? You add some error correction code in the transmitter. Then if you find this error, they use this one to correct. They correct the error at the receiver. So error is correct here. So they call it forward error correction. For ARQ is that you found it wrong, you will receiver will send ARQ as for another transmission. So ARQ, this is normal backward error correction. Backward means When I found the error, I request you to retransmit again. So from here, you can see the trade-off between the two. For error correction, you need to, the price you pay is the extra bit you transmit. But what's the price paid for ARQ? What's the price paid for ARQ? What? Delay. Okay, very good. Delay. You delay. You need to wait for a longer time. So the price you pay is the delay. So in communication, in general, you can have voice communication. You can have optical communication. But normally, ARQ, when do you need to use for error correction? Normally, in general, both of them will be applied. But you will have high error channel and the low error channel. For high error channel, you need to combine both. For low error channel, such like fiber, the failure rate is 10 minus 6, 7. So in this case, maybe you can consider to ignore. Don't implement this one because you can save your bandwidth. But actually, depend on what do you need. For voice, video, for voice communication, they always enable FEC because the channel condition change all the time. So your packet, if you don't have FEC at the receiver, your packet rate will be very high. So basically, you cannot have a good QoS. Okay, so here the third one is loss. So we have data rate, we have delay, we have loss. FEC and the ARQ, they are used to deal with loss on the network. Yes. How does codec? Okay. Codec we just mentioned for your video codec. For your video codec, you can use the previous frame. The block, for example. I can only show you the concept, but you can. In video codec, basically they transmit data in a block wise. So, for example, so you will have two successive frames. So, for example, this one was lost. Codec, they may use this one and the next one, but this one and maybe next one, because they will have buffer. So they can use this one and this one to a very simple way. They can just use this one to replace this part. If the motion is low. But in fact, they have different way to implement this, depend on your characteristic, depend on your video encoding scheme. But this is a simple way you can do. Okay. Any other question? So we just tell you potential QoS parameter and show you different kind of way. Then we start to talk about multimedia application. There are some basic values here in the next few slides. I will show you some values. You don't need to remember the main value, but you need to at least understand the range For example, one way delay requirement for interactive voice should be less than 200 milliseconds. Otherwise, if your delay variation is greater than 200 milliseconds, 250 milliseconds, your ear will notice that delay, and you will feel the quality is very bad. So the requirement we just mentioned, this is from user's perspective. The different user, their ear sensitivity of their ear are a little bit different. So they have a slightly different value. But this is on average. On average, they will set this as a penalty or the basic QS requirement. So for you, when you are doing some research, you will assume you will have some QS to be achieved. So you can use the table we show you later on for your reference. Don't come up with experiment. Show us your network can provide QoS service, and your delay requirement is 1 second for voice. Okay, it doesn't make sense. Normally, delay and the bandwidth bottleneck come from voice network. We just mentioned in the first class, we can start from core network, CU, DU, then RU. Then CU, DU, core network, actually they are interconnected by wireline network. Now most of them are optical fiber. The radio one, the RU, between the RU to the user is wireless. The bottleneck, delay and the bottleneck normally come from wireless. So that's why we will focus on the QoS for the voice network. So factor they influence application requirement include application activity level, user characteristics. So this is interactive or non-interactive. So do you need to have two people interactive work with the other? Is delay tolerance or intolerance? Delay sensitive or non-sensitive? Delay non-sensitive is delay tolerant. Delay intolerance is delay sensitive. Okay. And you will read different articles, they use different terms. Adaptive or non-adaptive, whether your application can adjust their data rate or not. For example, application, this is mission critical or not mission critical. So you can have different kinds of classification. But basically, QoS factor to deal with interactive and the non-interactive application, the major QoS factor is delay and the delay jitter. Okay. So normally interactive voice, the range is around millisecond. Streaming video is around second. So it tells us your ear is more sensitive to your eyes. Okay, so you can find out when you want to transmit your video, you can sometimes the video will not be smooth, but you always need to keep the quality for your voice. So it means that even you transmit video and voice at the same time, video and audio at the same time, you still need to prioritize. Okay, first reserve your priority to your voice, to your audio, then to video. Tolerance, intolerance. Tolerance, intolerance, they have two kinds of tolerance. Delay tolerance, intolerance. distortion towards. This is considering the packet loss rate. So for audio and video, we are able to tolerate some packet loss. But for money transaction, we cannot accept any big error. So this is a simple classification. Adaptive, non-adaptive means whether you are able to adjust your encoder or something. So there are two adaptive techniques. First one is rate adaptation. So the first one means that your application can adjust the data rate, similar like the one you use in YouTube. When the network condition is not good, we reduce resolution, reduce the frame interval. Or you can drop some packet, or you can increase the data rate, compression rate, or you can change the multimedia property, reduce the resolution, color depth. But anyway will cause the degradation of the perceived quality. Delay adaptation, we just mentioned how to handle the delay. You can use adjust playback point, or you can just discard the packet, or you can use digital buffer. So you have different techniques to deal with delay, deal with the data rate. Application critical, normally we have a very strict QoS requirement. So when we want to represent, so what we just mentioned is simple classification of different kinds of application. Now, if we want to define application requirement, we can have two common ways, quantitative, qualitative. So here is the key for QoS. Okay, how to characterize QoS? You can have two simple ways. How do you characterize whether your parent pay good enough money to you or not? You can, the first one is good or bad, right? This or it's better, this week is better than last week. So this is qualitative. Okay, qualitative. You said you can only say it's good, it's comparative. It's better or worse. Another one is give you a value. Quantitative expression give you a value. So let's talk about the money. So if you want to ask for money, first one is you tell your father, I want you $200 per week. This is quantitative. Qualitative, you can tell him, I want you more than last week you gave me. Okay. So this is which one is more difficult to achieve? Quantitative is more difficult to achieve because you need to meet the value. Okay, for example, you said that your father next week give you $100. You just tell him you want more. He can give you 100 for what? Give you extra $1 to meet your requirement, right? But if you tell him, I want to have 200, could be difficult for him to fulfill. I mean, from network point of view, from your parents' point of view, quantitative is more difficult to achieve because they need to meet the value. But considering the resources are limited, the basic assumption is resources are limited. if you have infinite resource, both are the same. How much you need, I just give you. So here are some requirements. You can see that different encoder, they will have different bandwidth requirements. This one is quality. Most is value they rank by the user. So the way they measure it is they find maybe 1,000 people to hear the voice, the same voice. Then they give a rank from 1 to 5. The higher value is good. Lower value is not good. So you can find that in general, voice, 64 are a major number. Are a major number for voice, because your voice, normally everybody, your voice is, the bandwidth for both your voice is around 4 kHz. Between 0 to 4 kHz. Somebody higher, but normally less than 4. So according to sampling theory, you need to sample 2 times. So it's 8 kHz per sample. 8 kHz sample. Per second. 2 times of sampling rate. Then 8 bits per sample. So in total, you get 64 kilobits per second. So 64 kilobits per second is the one you traditionally use in your house, your old telephone. Your telephone, digital telephone, they always use 64. So you will see, originally everybody used 64. You will not see 128. It doesn't make sense because your voice. But you can see, you can also use 8 kilobits per second. Or 64, you can use 12.2. This one are used in wireless network. GSM is stereo. Okay, so from stereo you can find 64, and we can also get very good quality like 64 with a very low bandwidth. The price we pay is you need to use very good codec with high compression. Okay, so the price we pay here, we trade off the bandwidth by complexity. Okay, nothing for free. You need to pay. Previous one is the bandwidth for voice. This one is the delay for voice over IP. So excellent quality, less than 100 milliseconds, 150 milliseconds. Okay. Less than 100 milliseconds, 150 milliseconds. Actually, your ear cannot notice. So the delay, less than 100 milliseconds is good. Another one is delay jitter. Delay jitter, normally we set it to 40 milliseconds. So you can get some simple golden value here. This is video codec. So you can see that higher resolution, higher bandwidth, their bandwidth is higher. So originally, most of them are fixed bandwidth. They also have variable bit rate. variable bit rate means your encoder can adjust. So MPEG 4, H dot 323. They also have some new codec, but now, so they just show you different requirements. So to make a conclusion for today, we want to characterize the QoS based on what kind of service is provided. So we have quantitative, qualitative, and the best effort. Okay. Quantitative is top priority, most difficult to achieve because you need to meet the value requirement. The second one is qualitative. Quantitative and qualitative, they provide QoS. Third one, base effort. Base effort do not guarantee any QoS. So don't tell everybody I try my best. Try your best. Do not offer any quality of service. From QoS term, okay? From QoS term, quantitative, qualitative, then base effort. So we have different levels. We also can offer QoS to different entities. We can offer QoS to individual, we call it control. To a group, we call it a class. Okay. So we have two kinds. We combine the two. So network may combine these two. Okay. Up to here, any question? No question? So let me answer the last question. How many combinations do we have for QoS? How many combination network can offer QoS? Somebody answer it, we can stop the course today. Or we can just wait until we get how many combinations? For those who did not raise any question, do you want to try it? We will not punish you, even you have a wrong answer. So try it. The point here is to encourage you to raise questions there. How many combinations? You usually it could be quite simple. We have 3, we have 2. Yeah. 6. How do you calculate 6? The number itself is not important. How do you calculate 6? Okay. 3 multiplied by 2 equal to 6. How about the others? Any? We have two numbers. You have different combination. You can plus, minus. You can have different combination. Any others? For those who agree 6, please raise your hand. Everybody agree 6. Okay, we have somebody who did not raise your hand. Means you have different number. No? Actually, it's 5. Why is 5? So we just, Joanna just said that 3 multiplied 2, right? So the total combination 3 multiplied by 2 is 6. But to remember, best effort without QS. Without QS, you don't need to consider per class of per flow. So you have quantitative per flow, quantitative per class. You have qualitative per flow. So the phi is 2 multiplied by 2 plus 1. They are 4. These 4, they provide QoS plus 1 best effort. Best effort don't provide QoS. So it's 5. Okay, this will be one of the questions in your final exam. Okay, let's stop here. See you next week. I will try to give you some assignment. So if you don't know where to, we will try to announce everything in our HackMD and on Google on our Moodle. So if you have any question, you can just you can join the live group. You can raise the question in the live group directly. Okay. Thank you. Thank you very much. Please check with, yeah. Yeah. You can come here to announce. you.